Okay, so I just went through all this process of solution and then I couldn't get the right answer I was looking for. Then I now went through this second process of solution and then I finally got the answer. How did it all start? Prove that 2a minus b all raised power 3 plus a minus 2b all raised power 3 all over a raised power 4 plus a squared b squared plus b raised power 4 equals to 9 into a minus b over a squared plus ab plus b squared. Now looking at this question 11, this is episode 5 relatively of assignment past question or assignment questions of Lasustech. Of Lasustech relatively. So let's go straight into the solution. What prove that this is equals to this? Now, what should you first do here? Now, you might say, let me expand this, then I'll bring them together, collect like terms, and then, factorize, after which, then factorize this also, cancel out if there's anything to cancel out and get your answer. Very good. Another way is such that you just factorize this with the idea I've taught you guys before, do with single variables like alpha, beta. So if I have alpha cube plus beta cube, how will it be like? And for this, if you follow us closely, you'll notice that we've done something like this before in our completed video. So we've done the factorize sum of this, which I'll be bringing in on board, and also another method you can even use to get the same expression in its factorized form. Anyways, let's go straight into the solution. Now we have this. So using alpha cube plus beta cube, the idea is going to say what? Assuming it was alpha cube plus beta cube, that is the same thing as what? Alpha plus beta all cube minus 3 alpha beta into alpha plus beta. I'm trying to try this one out for so we can easily see what we did in one of our videos like so. So I can easily solve this one now. Now apply this method to expanding this. Now becomes auto factorizing this. Now becomes what? It becomes 2a minus b plus a minus 2b all cube minus 3 2a minus b a minus 2b then into what? 2a minus b plus a minus what? 2b, as simple as this, all over a raised power 4 plus a raised power 2 b raised power 2 plus b raised power what? 4. Now this is the same thing as what? 3a minus what? 3b all cube minus, this is 3 into, you can expand this becomes what? 2a squared minus 5ab plus what? 2b squared, then into what? 3a minus what? 3b. Now let's continue with the process of solution. All over what? All over, don't forget, a raised power 4 plus a squared b squared plus b raised power what? B raised power 4. Now from here, what I first did in my solution that I showed earlier on was such that I expanded all this, expanding this, subtracted, collected like terms, added, and then factorized back and apply it with this, which relatively didn't give me the answer. So what did I apply as a second method? From here, it's best when you're factorizing, if you see anything common, make sure you just factorize it out already to make the work easier. Looking at this first expression, or this numerator as the expression, I have something common for this and this. This is 1, this is 1. So what's common? What's common is what? 3a minus 3b. What remains now becomes what? 3a minus 3b all squared, then minus 3 into 2a squared minus 5ab plus what? 2b squared. Just follow closely. All over what? A raised power 4 plus what? A squared b squared plus b raised power 4. And this is the same thing as what? 3a minus 3b into what? You have to expand this, subtract, collect like terms, and resolve, and then get your final answer. Expanding this becomes what? 9a squared minus 18ab plus what? 9b squared. Then expanding this becomes minus 6a squared plus 15ab minus 6b what? Squared. Okay, so all over what? A raised power 4 plus a squared b squared plus b raised power 4. Now collecting like terms now becomes what? Collecting like terms now becomes this is 9a squared. I have 9a squared, I have minus 6a squared. So that's 3a squared. Then I have minus 18ab plus 15ab. That's minus 3ab. Finally, I have 9b squared minus 6b squared. That's what? Plus 3b what? Squared. All over a raised power 4 plus a squared b squared plus b raised power what? B raised power 4. Now, from here, this is the same thing as if I bring 3 out here first, what remains? A minus b into what? 3a squared minus 3ab plus 3b squared all over this. And then bringing 3 out from this side now becomes what? 3 times 3, that's 9, into a minus b into what? A squared minus, that is what remains here, a squared minus ab plus what? B squared. Because if 3 comes out here, goes all over what? A raised power 4 plus a squared b squared plus b raised power what? 4. And then what do I then have? Now this is where I have to remind us the factored form of this according to our last class. Now from our last class, what do we have? We add the factorized form as what? As this. The factorized form is this. Now if I say this is the factorized form, let's now bring it into this our question. How are we going to do it? Now from here, this is actually stress, but let's just continue. From here, I can see this is the same thing as a squared plus ab plus b squared, a squared plus ab plus b squared, just expanding. Then this remains minus 2ab into a squared plus ab plus what? B squared. Now, quadratic equation. When you factorize like this, what happens? This is common, so make it as 1. A squared minus plus ab plus b squared. Then the rest you keep it in another bracket. That's this and this. So that's a squared plus ab plus b squared minus 2a. Minus 2ab, in this case. Okay, so minus 2ab. So this becomes a squared plus ab plus b squared, then into a squared minus ab plus b squared. That we're going to have. Why? Because this is ab, this is minus 2ab, so that's minus ab. So I'm supposed to write this down here because that's factorized form. So I have 9 into a minus b into a squared minus ab plus b squared over what? A squared plus ab plus b squared into what? A squared minus ab plus what? B squared. Now I said there's another method to getting the factorized form of this very quickly. Now let me show us up here. Now given a squared plus a raised power 4, in this case plus a squared b squared plus b raised power 4, and I said it's the same thing as a raised power 2 or raised power 2 plus ab or raised power 2 plus b raised power 2 or raised power what? 2. I can also say the same thing as a raised power 2 plus b raised power 2 minus a b. This should be this should be the answer. Plus minus ab also. How? Now from here, if this should be always power 2 here. So minus a squared b squared in that case then. So how? From here, if I say let me expand this, what will I get? I'm going to get a raised power 4 plus 2a squared b squared plus b raised power what? 4. Now what's the difference between this and this? The difference is that this is 2, this is 1. So if this is 2, this is 1, I can split it by saying a raised power 4 plus a squared b squared plus a squared b squared plus what? B raised power what? 4. So if I take this, this, and this, what remains? This remains. So it's by saying what? This all squared minus what remains? This. So the same thing happens here. So, and this is difference of two squares also. If this is difference of two squares, it means I can say a squared plus b squared plus ab, and then a squared plus b squared minus what? Ab. Difference of two squared. Or from what I just did earlier, I can also have it like this, which is exactly what I just said now. So now from here, this cancels out, leaving me with what? The solution to the question earlier what? Earlier asked. A squared plus what? AB plus what? B squared. As simple as that.